Okay, let's look at this example right here. So the graph of f is shown, and we've got our graph, and our graph here is in pink. I'm just highlighting the graph here to get an idea. And for the first question, we are asked to explain why the series 1.6 minus 0.8 x minus 1 plus 0.4 x minus 1 squared minus 0.1 x minus 1 cubed plus dot 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 is not the Taylor series of f centered at 1. And in order to figure this out, we need to look at the definition of the Taylor series of f centered at a point, say 1, centered at 1. And so remember, here's what is the Taylor series of f centered at 1? It's going to be f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 over 2 factorial. So each time we're going over 1 factorial, right? So then x minus 1 squared plus the triple derivative, the third derivative, over 3 factorial, x minus 1 cubed plus dot dot dot, right? So this would be our Taylor series for the function f centered at 1, because the general format, remember, is the sum n equals 0 to infinity, and then you have you have the nth derivative at the center over n factorial. That's your coefficient, and then x minus the center all the way to the nth power. Okay, so this is our general format for a Taylor series. And so since our center is 1, we get f of 1 plus f prime of 1 times x minus 1 plus da 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 da. Okay, so now we are given 1.6. So if this is the Taylor series, then this would be f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 over 2 times x minus 1 squared plus f triple prime of 1 over 3 factorial, right? Because let's see, so we've really got all of these factorials, right? Times x minus 1 cubed plus dot dot dot. So let's look and see. Could these match up? And the answer, even before we even get started, is no, these can't match up. Well, let's see here. Maybe they could. Because the first thing I'm looking at is I'm looking at f 1.6. Could that be f of 1? So now looking here, here's 1, my f of 1. So maybe that's 1.6. Okay. Okay, I'll take it. What about this? What about our second coefficient? Could negative 0.8 be f prime of 1 over 1 factorial? Now, why am I matching these up? I'm matching these up because the coefficient of x minus 1, on the one hand, it is f prime of 1 over 1 factorial. And on the other hand, it's got to be negative 0.8 if these two are the same, right? So if these two series are equal, then the coefficients are equal. F prime over 1, right, is just going to be f prime because 1 factorial is 1. So the issue is, can f prime of 1 be equal to negative 0.8? No, it cannot, because our function is increasing. So since our function is increasing, f prime of 1 has to be positive. So since f is increasing at 1, f prime of 1 must be a positive number. So f prime of 1 can't be negative 0.8. So that's our explanation. Therefore, thus, f prime of 1 is not equal to negative 0.8. Okay, now let's look at this one. Explain why the series 2.8 plus 0.5 x minus 2 plus 1.5 x minus 2 squared is minus 0.1 x minus 2 cubed is not the Taylor series of f centered at 2. Okay, so let's analyze the behavior of our function at or near x equals 2. So I'm just going to estimate that this is 2. Okay, so now if this is the Taylor series of f centered at 2, then here we've got f of 2, we've got plus f prime of 2 times x minus 2 plus f double prime of 2 over 2 factorial times x minus 2 squared plus f triple prime of 2 over 2 factorial times x minus 2 cubed plus dot dot dot. So let's do exactly what we did before, and let's try to match up the coefficients. 2.8, yeah, that could be f of 2, right? Because that looks pretty high. Nothing outrageous there. F prime of 2 is equal to 0.5. That makes sense, right? So if f prime of 2, could it be about 0.5? That's reasonable because look how this slope is not steep, right? So I could believe that 0.5 is the slope of the tangent line. What about this f double prime is equal to, right, f double prime over 2 factorial is equal to 1.5. So could f double prime of 2 over 2 factorial, could that be about 1.5? Let's see here. What is 2 factorial? 2 factorial is 2. So we're saying f double prime of 2 over 2. Could that be about 1.5? Could f double prime of 2 be about 3? No. Why not? Because at 2, our function is concave down, right? So the second derivative has to be negative. So to answer it, we would say the function, since f is concave down at x equals 2, f double prime of 2 must be a negative number. Therefore, f double prime of 2 over 2 factorial can't be, what was it? What did we say it was supposed to be? It was supposed to be like 1.5. Yeah, 1.5. Can't be 1.5. Therefore, that can't be the power series of f. So it'd be the Taylor series of f centered at 2. Right? Because if it's the Taylor series, then we know what the coefficients have to be, right? That's just what happens when you match up those derivatives. So that's our explanation.